Let's discuss this workflow. It's basically a WhatsApp chat agent that can function either as a sales assistant or a customer support representative. It's an RAG agent that responds to customer queries by leveraging an organization's internal documents. There are two main flows in this workflow. The first flow handles storing internal documents into a vector database. Let's break it down. It starts with a Google Drive trigger node that checks a specific folder in Drive every minute. In our case, the folder is named n8n test. The trigger watches for any file creation events in that folder. Whenever a new file is added, the workflow is triggered. The next node then downloads the file using its file ID fetched in the previous step. Next, we use the Supabase vector store, where the document goes through two steps. First, it's split into chunks using a recursive text splitter. Then, each chunk is converted into a vector using the OpenAI embedding model. These vectors are then inserted into the documents table in our Supabase vector store. To demonstrate this, we'll execute the flow. Right now, the documents table is empty. Once we upload a file to the n8n test folder, this table will be populated. Let's go ahead and upload a file. Since the flow is active, it should auto-execute shortly. Checking the execution logs, it succeeded. Now if we look into the documents table, yep, it's been populated. Now that the documents are embedded and stored, we move on to the second flow, which handles chat interaction. This part is triggered by incoming messages on WhatsApp. Once a message is received, it passes through a split out message node that extracts the message content. We've added a condition. If the message is audio, it follows a different path that includes extra nodes to convert it into text. If it's text, it skips those extra nodes. For audio messages, the WhatsApp node fetches the audio URL. Then, using the WhatsApp API, we download the audio and send it to Google's Gemini 2.0 Flash model to transcribe the speech into text. Once the transcription is complete, we extract the text output using an edit node. From there, we also grab additional metadata like message type, session ID, and so on. These help us later when crafting a response. Next, the extracted text is passed to the AI agent which uses GPT-4o Mini to generate a reply. To maintain conversation context, we use PostgreSQL as a chat memory backend within Supabase. The session ID helps associate chats with their history. The agent also accesses the Supabase vector store using the same documents table we populated earlier. Based on the user's query, relevant chunks from the knowledge base are used to formulate a meaningful response. The chat history and relevant chunks from the vector store are then passed to the agent, where we've instructed the model to use only the provided context to answer. If it doesn't find anything relevant in the knowledge base, it should not make up answers. Instead, it should simply inform the user that it doesn't have information on the query. Once the response is generated using the OpenAI chat model, we use a WhatsApp send node to deliver the reply back to the user. Let's test it now. I asked about Web3 related services and the agent gave a relevant reply. We can even send voice messages as input. For example, how to contact Terzeto Labs. The agent responded properly. So, whether it's a text or voice input, the agent is able to understand and respond accurately. That's it for this video. See you next time.